Hey, today we're going to go over Chapter 1.8. And Chapter 1.8 is sort of introduces and discusses in more detail the three subatomic particles that we introduced in our last lecture and the discovery of them and some of the scientists that worked on them. And these include the electron, the proton, and the neutron. Now, all atoms have, I would say most atoms, we're going to show that one doesn't have one particular subatomic particle, and we'll discuss that in a few minutes. But most atoms have all three of these particles in them. They have electrons, protons, and most of them have neutrons in them. So what is unique for a particular atom? In other words, which of these particles is responsible for helping us to identify an atom of a particular element? And that is the number of protons. The number of protons are unique for an atom of a particular element. And we're going to be discussing that a little bit more in detail today. And finally, we're going to introduce the topic of isotopes. And isotopes are atoms of a particular element, so they have the same number of protons, but they have different numbers of neutrons. And that's another topic we'll be introducing in today's discussion. So let's begin with the protons. So as we said, rehashing, the number of protons are unique for an atom of a particular element. If we look at the periodic table, we would see how the periodic table has different boxes for all of our different elements, and they have their symbols. In this box that I have on the PowerPoint listed today, and as I'm discussing here, we see that this box has a 6, it has a C, and it has 12.011. Well, periodic tables sometimes are arranged a little differently. The numbers might be in a corner. Sometimes they might have more digits in that decimal portion. But we're just going to understand a little bit about some of the general features of these boxes on the periodic table. Now, the C tells us that this is an atom of carbon. That's the abbreviation we use on the periodic table for the elemental symbol of carbon. Now, this whole number 6 that sits above that C, that's known as the atomic number. Now, the atomic number is the number of protons in that particular atom. And so what this tells us from the periodic table is that all atoms of carbon have 6 protons. If you find an atom and it has 6 protons, you could be sure that that's an atom of carbon. A little bit later, we'll discuss more about this decimal number, this fractional number. 12.011, as we discuss later, will be called the average atomic mass. So as an exercise, you should be able to look at the periodic table and you should be able to answer questions. For instance, if I said to you, how many protons are in an atom of sulfur? You would look on the periodic table, you would see that whole number 16, and that would tell you that sulfur atoms have 16 protons in their nucleus. I could also ask you which element has 12 protons in it. Again, you would look for which element has the whole number 12. That whole number 12 is the number of protons, and you would see that that has an elemental symbol of Mg, which is magnesium. So that's important for understanding about elements. The number of protons, again, are unique for an atom of a particular element. So let's move to another topic that's related, and that is how we define atoms with different numbers of neutrons. And these are called isotopes. So isotopes are our next topic. Isotopes, well, they have for an isotope of a particular element, they would all have the same number of protons. So an isotope is going to be an atom of a particular element because they have the same number of protons, but they have different numbers of neutrons. So that's how we define an isotope. And when we think about isotopes, we have a nuclear symbol for them, a shorthand way of representing isotopes that would be given to you. And these are oftentimes given to you in a discussion on substances that exist as isotopes. We have a notation. So that's what an isotope is. Let's go through a notation to represent an isotope. So a notation that we use, X, A, and Z. So let's discuss a little bit about what these mean in terms of this notation. X is going to be a letter or a series of letters, 2 letters the most. And X is going to be the elemental symbol. And we'll go over several examples. A is called, it's a number, and it's called our mass number. The mass number is equal to the number of protons plus the number of neutrons in an atom of that particular isotope. Z is the number that we discussed a little earlier. Z is the atomic number that we showed a little bit earlier for carbon. Z is the number of protons, and it's called our atomic number. So that's a notation that we often see when we're discussing isotopes of a particular element. Now, as I said earlier, all atoms have protons, they have electrons, most of them have neutrons. There is one unique case, and that's for hydrogen. We're going to go over the 3 isotopes that are most common for hydrogen to help us understand how to use this notation. So we're going to look at the isotopic notation for the isotopes that exist for hydrogen. So let's look at hydrogen. Hydrogen, if you go to the periodic table, you would see that hydrogen has a 1 associated with it, and there is a number here, 1.008, and that's what you see in the periodic table. Now, hydrogen exists in 3 abundant isotopes, 3 naturally occurring isotopes. The most abundant naturally occurring isotope has a name to it, and it's called protium. And again, when we think of our notation, remember the atomic number, Z, is the number that's found in the periodic table right there. That's its atomic number. Now, the mass number is the number of protons plus the number of neutrons. So for this isotope of hydrogen, this is the unique case. The most common form of hydrogen doesn't have a neutron. It's just the way hydrogen exists. And since it has no neutrons, the number of neutrons plus the number of protons, its mass number, is equal to 1. So let's keep track here. Let's write down the number of protons, P, 1. The number of neutrons, For this isotope of hydrogen, it's 0, and the number of electrons. Hydrogen is a neutral atom, and for atoms that are neutral, the number of protons are equal to the number of electrons. Both of them are equal to 1. Let's look at another naturally occurring isotope of hydrogen. I'm going to erase the name here so we have a little room. The second most abundant isotope of hydrogen is called deuterium. Since it's an atom of hydrogen, well, it does have 1 proton, but this particular isotope of hydrogen has 1 neutron. So its mass number is 2. So let's keep our table. The number of protons is the atomic number. It is 1. The number of neutrons is 1. And since it's a neutral atom, it has 1 electron. So this mass number here is the combination of these two, the number of protons and the number of neutrons. And that's deuterium. A third isotope of hydrogen that's fairly common is known as tritium. Since it's an atom of hydrogen, it has a single proton, but this particular isotope has 2 neutrons. So it has a mass number of 3. Let's maintain our table. It's an atom of hydrogen. It's an isotope of hydrogen. It has a single proton. This particular isotope of this atom of hydrogen has 2 neutrons. And since it's a neutral atom, which is an isotope of hydrogen, it has the same number of electrons as protons, 1. It's the combination of these two that give us our mass number of 3. So it's the number of protons and the number of neutrons on how we distinguish our mass number for a particular isotope of an element. Now, we also have shorthand notations that you might see. I gave a shorthand, so you might want to just look at that. Let's look at a case, and let's look at carbon, a shorthand notation, C14. That's carbon 14. Sometimes it's written as now, the shorthand notation uses a whole number to represent the mass number, because we can look on the periodic table and we would recognize that carbon has a atomic number of 6. So how many protons does carbon 14 have? Carbon 14, as it's written here, we would know it has 6 protons because that's the number we would see on the periodic table. How many neutrons does carbon 14 have? Okay, let's think about it. This is carbon 14. This number is the mass number when we use our shorthand notation. The number of neutrons is equal to 8. The number of electrons, well, this is a neutral atom, and we'll discuss ions in a little bit. Protons and electrons are going to be equal for a neutral atom. So this is a shorthand notation that you oftentimes will see instead of writing it out completely, because what they assume that this is the mass number you can use the periodic table to find the atomic number, such as we discussed a little earlier. I have a few that you want to try on your own. Try this one on your own. Bromine 79. Now, if you look on the periodic table, you would need to find bromine's symbol. And you would find what bromine's whole number is. So find the atomic number from the periodic table. This is the mass number. So if you were asked how many neutrons are in bromine 79, the number of neutrons are going to equal the mass number 79 minus the atomic number that you would find on the periodic table. And as an exercise, I want you to find out the number of neutrons in bromine 79, and we'll go over that as a review for our next lecture video. And we'll finish up with isotopes, we'll discuss ions, and we'll go into the mole concept. Thanks a lot. Have a nice weekend.